Hello everyone, this is Dharamveer sir here. So today we are going to continue with chapter 7 of grade 11 maths, which is permutations and combinations. And the topic of today's video is permutations. So let's start. So first of all, let me tell you the meaning of permutation. So permutation is an arrangement of objects in a definite order, that we arrange the given objects in a particular order. So remember that order does matter in case of permutation. Now the number of permutation of n different objects, out of which we are taking r at a time, is given by npr, and npr is equal to factorial n upon factorial n minus r. I hope you remember the meaning of factorial. So you can simply calculate the value of npr. Now npr is defined only if n belongs to natural number, r belongs to whole number, and r should always be equal to less or equal to n. Clear? R cannot be greater than n. Clear? So pause and note down this point. Now a few very important points to remember, that npn, that is if we are taking all the n objects out of n objects, is equal to factorial n. Clear? Second is npn minus 1 will always be equal to factorial n, and np0 is equal to 1. Now a very important point, that the number of permutation of n objects, not all distinct, taken all at a time, when p are of the same kind, q are of the same kind, and r are of the same kind, is given by factorial n upon factorial p into factorial q into factorial r. Clear? Remember this point, that if of the n objects we have few objects which are of the same kind, then we use this formula, factorial n upon factorial p factorial q into factorial r. Clear? So pause and note down these very important points. So let's start exercise 7.3, and the question 1 is, how many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? Remember the condition, that no digit is repeated. So we have 3-digit number, that is 100, tens and unit place, and there will be as many as 3-digit numbers as we can fill the digits 1 to 9. Now since digits are not repeated, so it can be 9p3, because we are taking 3 out of 9, which is equal to 9 into 8 into 7, that is 504 ways. So the required number of 3 digit place can be filled in 9 ways, tens will be filled in 8 ways, and unit place will be filled in 7 ways. So using the fundamental principle of counting, it will be 9 into 8 into 7. Clear? So you can go in any of these ways. So pause and note down the solution. Next we have question number 2. How many 4-digit numbers are there with no digit repeated? Now we know that the number of digits from 0 to 9 will be 10, and the 1000 place can be filled in 9 ways, excluding 0, because 0 cannot be at the 1000 place, otherwise it will become a 3-digit number. And the 100 place can be filled in 9 ways, tens place will be filled in 8 ways, and the ones or the unit place will be filled in 7 ways. So using the fundamental principle of counting, the total number of 4-digit numbers will be 9 into 9 into 8 into 7, which is equal to 4536. Remember this, that the first place, that is 1000 place, cannot have 10 digits, because the 0 cannot be at the 1000 place, otherwise it will be a 3-digit number. Okay, so pause and note down the solution. Next we have question number 3. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6 and 7 if no digit is repeated? As you can see in the box, and we need only even number. So at the unit place we can have either 2 or 4 or 6. So there are 3 possibilities for the unit place. Now the other 2 places, since these are not repeated, so out of these 6 we have used any one over the unit place. So 100 will have 5 possibilities, and the tens will have 4 possibilities. So total number of 3-digit even numbers will be equal to what? 3 into 5 into 4. Clear? Which is equal to 60. So pause and note down the solution. Next is question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman assuming one person cannot hold more than one position. So we have two posts only, one is chairman and the other is vice chairman, and we have 8 people. So number of possibilities at the chairman's place, any one of these 8. So we have 8 possibilities at chairman's place, and if we have selected any one at the chairman, we are remaining with 7. So number of possibilities for the vice chairman will be equal to 7. So again, using the fundamental principle of counting, it will be simply 8 into 7, that is 56. Or if you want to go through permutation, out of 8 we are selecting any 2, so it will be 8p2, that is 56 ways. Clear? So pause and note down the solution. Next is question 6. Find n if n minus 1 p3 ratio n p4 is equal to 1 ratio 9. Now we have n minus 1 p3 upon n p4 equals to 1 upon 9. So using the formula for npr, we get n minus 1 into n minus 2 into n minus 3 upon n into n minus 1, n minus 2, n minus 4, which is equal to 1 upon 9. So cancelling everything, we are left with 1 upon n equals to 1 upon 9. So by cross multiplication, we get n equals to 9. So in this sum, we have simply used the formula for npr, which is factorial n upon factorial n minus r for both the numerator and denominator. Clear? So pause and note down the solution. Next is question 7. Find r. There are two parts, and solving the second part, that is 5pr equals to 6pr minus 1, which will be equal to factorial 5 upon factorial 5 minus r equals to factorial 6 upon 6 minus r minus 1. So we get factorial 5 upon 5 minus r factorial equals to 6 into 5 factorial upon 7 minus r factorial. So factorial 5 will be cancelled from both sides, so we are left with 1 upon 5 factorial 5 minus r equals to 6 upon 7 minus r into 6 minus r upon factorial 5 minus r. So factorial 5 minus r will be cancelled from both the denominators, so we are left with 1 equals to 6 upon 7 minus r into 6 minus r. So cross multiplying, we get 42 into minus 13r plus r square equals to 6, which will be equal to r square minus 13r plus 36. So by middle term split, we get r minus 4 into r minus 9 equals 0, or we are left with r equals to 9 or r equals to 4. Now we know that r cannot be greater than n, and here in place of n we have 5 or 6. So r equals to 9 is not applicable, so we are left with only one solution, that is r equals to 4. Clear? So pause and note down the solution. So moving to question 9. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated? And there are 3 cases. First is 4 letters are used at a time, all letters are used at a time, and all letters are used but first letter is a vowel. So coming to the first one, 4 letters are used at a time. Now 4 out of 6 can be arranged in 6p4, and 6p4 equals to what? 6 into 5 into 4 into 3, that is 360. Clear? Second, we have all letters are used, that is 6 letters out of 6 letters have been used. So again, using permutation, it will be equal to 6p6, that is factorial 6, and factorial 6 equals to 1 into 2 into 3 into 4 into 5 into 6, which is equal to 720. Third is, the first place can be filled by any one of the two vowels, O or A. So first place we have 2 possibilities. Now the remaining 5 letters can be arranged in the remaining 5 places. 5 out of 5, that is 5p5. So again, by the multiplication rule, we have 2 into factorial 5, that is 2 into 1 into 2 into 3 into 4 into 5, that is 240. Clear? So pause and note down the solution. Moving to question 10. In how many of the distinct permutations of the letter Mississippi do the 4 I's not come together? Okay, so we have 11 letters in the word Mississippi, and not all are different. So we are going to use that theorem, factorial n upon factorial p factorial q factorial r over here. So total number of arrangements will be equal to factorial 11 upon 4 i's are there, so factorial 4, 4 s are there, so factorial 4, and 2 p's are there, so factorial 2, which is equal to 34,615 by using factorials. Now we are going to consider all the 4 i's as a single block and treat it as a single letter. So we are getting 4 i's together in the bracket, then s, 4s, there are 2p and 1m. So total units will be equal to what? 8. So we have 8 letters or 8 units. which can be arranged in factorial 8 upon factorial 4 because there are 4s, and factorial 2 because there are 2p. So which is equal to, that is all the 4 i's are coming together will be equal to 840. So we have the total number of arrangements, we have the arrangements in which all i's are coming together. So the arrangements of the permutation in which 4 i's will not be together will be total minus number of arrangements in which 4 i's are together. So this is equal to 34650 minus 840, that is 33,810. Clear? So pause and note down the solution. So next we have question 11. In how many ways can the letters of the word permutations be arranged if the word starts with P and ends with S? Second, vowels are all together. And third, there are always 4 letters between P and S. Now first part, the permutation has 12 letters and not all are different. So again we are going to use the theorem factorial n upon factorial p into factorial q into factorial r. So it is clear that letter P is at one end and the S is at the end. So we have to arrange only the 10 letters. So it will be equal to factorial 10 upon, since there are 2 T's, so divide by factorial 2. So we will get 1814400. This is the condition when the word is starting with P and ending with S. Now coming to the second part, the word permutation have 5 different vowels A, E, I, O, U and 7 remaining consonants, in which T is twice. So again taking all the vowels as a single unit, we will have P, M, T, R, M, T, T and S. So we are going to arrange these 8 units and in these 8 units the T is appearing twice. So total number of ways will be factorial 8 upon factorial 2. Now the vowels, all the 5 vowels can be arranged in factorial 5 because 5p 5. So we have factorial 5. So using the multiplication principle, the total number of ways in which all the vowels are coming together will be factorial 8 upon factorial 2 into factorial 5, which on simplification gives 2419200. So third part, now it is given that there are always 4 letters between P and S. Therefore P and S can occupy first and sixth, second or seventh, third or eighth, fourth or ninth, fifth or 10th, 6th or 11th and 7th or 12th. So there are P and S can occupy 2 places out of 12 in 7 different ways. Also P and S can be interchanged, P and S or S and P. So and the remaining 10 places are filled with factorial 10 upon factorial 2 because 2 T's are there. So remaining 10 letters are arranged in factorial 10 upon factorial 2 and P and S can be arranged at 7 into 2. 7 for P and 7 for S. So the required numbers will be 7 into 2 into factorial 10 upon factorial 2, which on simplification gives 25401600. Clear? So pause and note down the solution. With this we end exercise 7.3. So solve the remaining sums and also solve the examples given before the exercise. Thank you and all the best.